Okay guys, this week we're going to be looking at cosine rule, very similar to sine rule, which we were obviously considering last week, are rules that are going to help us work out a missing side or a missing angle in a non-right angled triangle, so where we couldn't use SOHCAHTOA or Pythagoras. Okay, this rule also encompasses the questions that sine rule doesn't let us work out. So with sine rule and cosine rule, we need different amounts of information, different sets of information, and next week we're going to look at how we differentiate that, how you can tell if a question is sine rule or cosine rule. Okay, but this week we're really just going to practice cosine rule. I'm going to do a couple of examples, so an example working out a side and an example working out an angle. You've got a cosine rule basics worksheet that's just literally doing that. You probably don't want to do that full worksheet unless you kind of feel like you need the practice. Just doing a few from each question will probably be enough. And then you've got the textbook, okay, and in the textbook there's a couple of questions I'm going to get you to miss out anything that involves bearings, basically, because we're going to look at bearings as a kind of whole topic in a couple of weeks' time. Okay, so anyway, cosine rule. The cosine rule formulas are both given to you on the sheet, on the formula sheet that you'll use for any assessment. So when we're working out a side, which is what we're going to do for the first example. Okay, so when we're working at a side, the formula is a squared equals b squared plus c squared minus 2bc times cos a. Now be really careful with this bit here. Okay, it's really easy to drop one of those C's and then we're going to get the answer wrong. In fact, I tried to make a video for you a couple of minutes ago and I realised I'd done that, so it's really easy to do. Just be careful, folks. Okay, so it looks like we're labelling our triangles in the exact same way, and we are. Our triangles are going to be labelled A, B and C for our angles, and then obviously small a, small b and small c, the sides across, for the sides, just like we did with sine rule. In the textbook it gets you to play about with that a little bit, changing the letters and so on, but you know that I'm happy for you to just relabel your triangle in whatever way you need to. So little a is always going to be the side that we're trying to work out. So here, that's I'm going to call that x, okay? Looking at the formula, to use the cosine rule, we need the other two sides. We need small b and small c, lowercase b and c. Let's just have 35 centimetres and 27 centimetres, okay? So we would be able to have a squared equals b is 27, so 27 squared plus c is 35, so plus 35 squared minus 2 times b, which is 27, times c, which is 35, times cos of a, and a is the angle, remember, so we're going to need to know what this angle is. Let's say that angle is 18 degrees, okay? So, at this stage, you grab your calculator. We've put in b and c, and cos a. So we just grab our calculator at this stage and type the whole thing in, 27 squared plus 35 squared minus 2 times 27 times 35, make sure you've got that c in there, it's not been absorbed with the cos, and then times cos 18. Making sure your calculator says d at the top for degrees, and we get 156.503 and so on. Okay, so leave it as your unrounded answer, but keep it on your calculator screen. Look at this. This is a squared. We're trying to work out the length of the side, which means we want a, so we're going to have to square root this 156.503. Okay, so we take the square root of that, and we get 12.5 centimetres. Okay, it's 12.510. I'm going to round it to 12.5. Okay, I should really have written my unrounded answer in there first. Okay, I'll just slide that in there. So that's how you work out a side. Okay, and I'll do another one. Okay, I was just going to do one of each, but I'll maybe do two of each just so you've got a couple of examples. don't know if you notice, but you've got this angle and you've got the side either side of the angle, the sides that make up the angle. That's really what you're looking for when you do cosine rule. You're looking for all of the information around one point. Let's do just one more side example just in case that helps, okay? And then I'll clear the screen and I'll turn these into angle questions. Okay, so this time I'm going to tell you that this angle here is going to be 72 degrees. Okay, I'm going to tell you that this side here is 40 millimeters, and I'm going to tell you this side here is 32 millimeters. Okay, so we can work with any types of measurements. That could be, we could have had 4 centimeters and 3.2 centimeters. You can work in kilometers, it doesn't matter. Now the triangle might well be labelled PQR instead. You can rearrange the formula if you want. It would be q squared equals p squared plus r squared minus 2pr cos q. Okay, but I think it's much easier for you guys at this stage just to go, do you know what, that needs to be A because it's the angle that I know, and these ones can be B and C either way. Also notice you've got the angle and the sides either side of it. That's what we're looking for cosine rule. Anyway, let's go on with the actual question. So, a squared, that's what we're trying to work out. Let's call it x. A squared equals b squared plus c squared minus 2 times b times c times cos a. Okay, making sure we've got that double c in there. So, a squared, b is 32, so 32 squared plus c is 40, so remember it's the side across. So 32 squared plus 40 squared minus 2 times 32 times 40 times cos of 72 degrees. Okay, so when we type that into our calculator, you can just type it in a oneer. You don't need to do it in stages. Your calculator should do all the BidMath stuff for you. Just be careful if you're using the calculator on your phone. Make sure, maybe try these questions just to make sure it's setting up and giving you the answers in the same way that I get them. Now, this time we get a much bigger number. Because it's a squared to begin with, remember this probably will be quite a big number to begin with, okay? So don't panic if you get quite large numbers for a squared. Okay, we can always double check that it seems correct when we square root it. So, a squared, 1,832.916 and so on, but we don't want a squared, we want a. So we're going to square root that big number. I'm just going to put 0.9 dot dot dot. Remember, give your unrounded answer first. I was a wee bit lazy in the last question, I'd kind of forgotten to do that, so I'm going to do that now. So, unrounded answer first of all, 42.8125 and so on. And again, round it sensibly unless the question tells you to round it to something specific. 42.8 millimeters will do for me. So that's how we work out a side. I'm just going to clear these diagrams and we'll look at how we work out an angle. Okay, so when we are working out an angle, we have a slightly different version of the formula. Now, unlike sine rule, where you've just got to remember and turn the formula upside down to make life easier, the angle formula for cosine rule is given to you on the formula sheet because it is a wee bit more complicated in terms of you can have a go at it, you can have a go and try and achieve it from the first formula I gave you. It's cos A equals b squared plus c squared minus a squared over 2bc. Okay, so it is really just a rearrangement of the formula that we've just looked at. Okay, as I said, some of you might want a wee challenge to go away and try and do that with your changing the subject knowledge. Okay, but it is given to you on the formula sheet, so you don't need to worry about creating it yourself. Same things apply, okay, in terms of the way the triangle is going to be labelled. So let's say we're going to work out this angle A here. Okay, so I'm going to call this angle A. Let's just call it x degrees, okay, or sometimes it might be called theta, remember. Okay, and in order to get this angle, I'm going to tell you that this here is 4.5 centimetres. And this length here is 3.2 centimetres. And then our top length, okay, is going to be 6.2 centimetres. Okay, now I'm just going to double check that everything's going to be okay with this. These questions are a wee bit trickier for me to make up because sometimes you can put in numbers that actually don't make a triangle. Okay, so I always just need to be a wee bit careful here. So, okay, we're just actually going to change this just to 6.1 just to make sure that this works okay. Okay, so same idea as before, folks. We've got A, B, and C. Okay, so this side here, the 6.1 is little a, 3.2 is your little b, and 4.5 is your little c. So when we're putting it into the formula, we're trying to work out the angle A, cos A. So we've got b squared plus c squared first of all. So 3.2 squared plus 4.5 squared. Okay, take away a squared, so take away the 6.1 squared, and then divided by 2 times b, which is 3.2, times c, which is 4.5. Now, it's really important in these questions, guys, that you get your a, b, and c sides labelled the right way round. Otherwise, you will end up sometimes with a wrong answer or sometimes with an answer that won't work, and you'll wonder what's going on. Now, it's totally up to you. Okay, when I was a pupil, as we know, it was a wee while ago now, and sometimes, okay, it was easier for me to work out the numerator and the denominator separately. Okay, so to work out that top line, this is still not working. Would give me, let me just show you this, okay, and show you what the problem is. And when I work out the top line, I'm getting minus 6.72, okay, and then when I work out the bottom line, I'm going to get 2 times 3.2 times 4.5, which I get 28.8. Okay, so that's okay. Okay, this is absolutely fine as a question. It might confuse you a little bit that we've got a negative number. Don't worry, all that negative number means is we're going to get an obtuse angle here. But that's what that looks like anyway. So when you have a negative fraction, you're expecting an angle more than 90 degrees for A. So that's a good sign. So you can work it out like that. You can tidy up the numerator and the denominator, or you can just type it straight into your calculator, that whole fraction, just making sure that you're careful with that. Either way, you should get an answer of, when we work out that little sum there, minus 6.72 divided by 28.8. Your calculator might give you minus 7 over 30. Okay, or you might have it as a decimal, which would be minus 0.23 repeater, so 23333. But remember, that's not the size of the angle, that's cos of the angle, that's cos A. Okay, so in order to get A, we're going to have to do inverse cosine, just like you would in SOHCAHTOA. So A is going to be the inverse cosine of, let me keep the fraction, we like exact values, so minus 7 over 30, but I've got that 0.233333 on my calculator screen anyway. Okay, so I'm just going to do shift cos on my calculator to get inverse cos, and I get an answer of 103.4933. Okay, so 103.5 degrees or just 103 degrees would be my answer. So that's how we do an angle, remembering that if we get a negative fraction, it's going to give us an obtuse angle. So let's do one where we're not going to get a negative fraction for our second example. So I'm going to tell you that this is 0.3 kilometres, this is 0.5 kilometres, and this is 0.25 kilometres. And we are going to work out this angle up here. Okay, so let's call that one A. Okay, so we've got B and C are our other two sides. We know all three sides and we're trying to get the angle, so it has to be cosine rule. Little a, little b, and little c. Okay, so writing out my cosine rule. Okay, I'm just going to start it down here. Cos A equals b squared plus c squared minus a squared over 2bc. Okay, and then we put in our numbers. I'm just going to work horizontally for a second to get the numbers in, and then I'll go vertically from there. You know you should be going vertically. Okay, so b squared is 0.3, c squared is 0.5 squared. A squared is going to be minus 0.25 squared. All divided by 2 times b times c, like so. So again, up to you. I'm just going to type it into the calculator in a 1er this time using my fraction button. 0.3 squared plus 0.5 squared minus 0.25 squared, and then on the denominator 2 times 0.3 times 0.5. Okay, and I get 0.925 as a decimal or 37/40. So either answer would be acceptable. 0.925 is quite a nice one because it's a whole decimal. Okay, in terms of it's one that has an end point. Whole's not the right number to describe it, but you know what I mean with that. Okay, so we've got cos A equals that. We're trying to get A on its own, so we need to do inverse cos of either the 0.925 or the 37/40, whatever you prefer. Okay, I tend to go with a fraction because it's more exact. So inverse cosine of 37/40, okay, it gives me 22.331 and so on. So I'm going to go with 22.3 degrees for A or for X, depending on what one you want to call it. So that's cosine rule. It is literally just like doing sine rule, but 2 different formulas to use. Hopefully you'll get on okay with it, but I'll be on the lessons all week if you're not sure.